Welcome to Class 8, Mathematics Chapter Power Play. Today we have a fascinating puzzle. 2 to the 4 times 3 to the 6, 6 to the 4 times 3 squared, 6 to the 10, 18 squared times 6 squared, and 6 to the 24. They all look completely different, right? But some of them are actually the same number in disguise. We break down questions step by step to help you understand better. Hit like and subscribe to support the channel. Before we dive in, let us grab our two secret weapons. First, break every number down to its prime factors. 6 equals 2 times 3. Simple. And 18 equals 2 times 3 squared, because 9 is 3 times 3. Second, when bases match, add the powers. N to the a times n to the b equals n to the a plus b. For example, 2 cubed times 2 to the 4 equals 2 to the 7. We will use both of these over and over. Our first expression, 2 to the 4 times 3 to the 6, is already written using only prime factors. This becomes our reference. Notice the only bases are 2 and 3. Every other expression needs to be converted to this same format so we can compare. This is our target. Now for 6 to the 4 times 3 squared, let us break it down. Here is our expression. First, 6 equals 2 times 3. So 6 to the 4 becomes 2 times 3, all to the 4th power. See how the 6 splits into 2 times 3 inside the brackets? Now distribute the power. 2 times 3 all to the 4 gives us 2 to the 4 times 3 to the 4. Bring down the times 3 squared that was already there. Now look, 3 to the 4 times 3 to the 2. Same base, so add the exponents. 4 plus 2 equals 6. And look at that, we get 2 to the 4 times 3 to the 6. It matches our reference. This one looks trickier. 18 squared times 6 squared. But we just need to be systematic. Here is our expression. First, what is 18 as a product of prime factors? 18 is 2 times 9, and 9 is 3 times 3. So 18 is 2 times 3. So 18 is 2 times 3 squared. Now 18 squared becomes 2 times 3 squared all squared. Distribute the power. 2 squared times 3 squared squared. Squared da. Power of a power. 3 squared squared das is 3 to the 2 times 2, which is 3 to the 4. So 18 squared equals 2 squared times 3 to the 4. Now for 6 squared, we already know 6 is 2 times 3. So 6 squared is 2 squared times 3 squared. Here it is. Now multiply them all together. 2 squared times 3 to the 4 times 2 squared times 3 squared. Group the 2's together and the 3's together. 2 squared times 2 squared. Add exponents. 2 plus 2 is 4. So 2 to the 4. And 3 to the 4 times 3 squared. 4 plus 2 is 6. So 3 to the 6. So 3 to the 6. 2 to the 4 times 3 to the 6. Another match. What about 6 to the 10 and 6 to the 24? 6 to the 10 is 2 to the 10 times 3 to the 10. That is way bigger than 2 to the 4 times 3 to the 6. Clearly different. And 6 to the 24 is 2 to the 24 times 3 to the 24 times 3 to the 24. Even bigger. Also different. The exponents do not match at all. And there we have it. 2 to the 4 times 3 to the 6, 6 to the 4 times 3 squared, and 18 squared times 6 squared are all the same number. They all equal 2 to the 4 times 3 to the 6, which is 11,664. Here is the reusable technique. First, convert every base to prime factors. 6 becomes 2 times 3. Second, distribute powers using the product rule. ab to the n equals a to the n times b to the n times b to the n. Third, combine same bases by adding exponents. N to the a times n to the b equals n to the a plus b. And then, just compare. Different outfits. Same number underneath. Numbers can wear many disguises, but prime factors always reveal their true identity. Now you can strip away any exponent costume and see what is really underneath. Keep learning and keep growing. See you in the next question.